All right, we're live. Happy Friday, everyone. Today is January 19th, and this is episode 35 of Get Your Tech On, our show on all things DOCSIS. I'm Brady Volpe, founder of the Volpe firm and Nimble This. With us is John Downy, the Punxsutawney Phil of cable. John is also on mute, and John is also technical expert leader at Cisco Systems. John, welcome back. Glad to have you with us again.
It's not February 2nd yet.
Oh, what I say? Yeah, it's coming up, you know. So John, you're over a satellite connection coming to us from your new home, right?
Correct.
Awesome.
I'm a little wary of the latency and stuff, but we'll see how well this does with the audio and video. Okay,
well, we'll see how it goes. Also back with us is Asaf, Matatyaou of Harmonics, the man in cable who runs at close to the speed of light. Asaf is also Vice President of Solutions and Product Management, Cable Edge Business of Harmonic. Asaf, welcome back. So glad to have you back with us again.
Thanks for having me back. I'm looking forward to it.
Thank you. And finally, new with us is Laufer, sci-fi fan who also recommends starting to read the Harry Potter book series, starting at book number 4. You can skip 1 through 3. Tal is also director of product line management at Arris. Tal, so glad to have you with us today, and actually tonight, your time.
Yeah, thanks a lot, Brady. Excited to be here. Don't give away all my secrets at once.
Well, you know, I was really glad talking to you because I'm a huge sci-fi fan myself, and you gave me the tip about, I really was not into the Harry Potter movies, but you said that the books are really good. So I'm a huge reader, and I look forward to starting reading at book 4, Harry Potter. So fantastic lineup today. This is actually probably I think the biggest lineup we've had for one of our Hangouts, and our topic is R-PHY. This is really a popular topic that we've had also in the past. And I'd like to kick off a question from one of our readers. And the reason I want to do the question first is we have a huge backlog of questions, but we never ever get to them because we always run everything up to the last hour. So one of our listeners, Stuart, asks, what are the benefits of moving all IP to the fiber node with R-PHY other than reduced size in the head end, reduced cooling and power needs, and shortening the distance? Does that mean CCAP architectures will be evolved to DAA? So I'll toss out the question, and we'll start with Asaf, just
Sure.
because you're first on my screen, Asaf.
All right. Well, first of all, saving power, space, and being cost effective are really important values in the remote PHY architecture to begin with. But as you get closer, as you get smaller service group sizes with the remote PHY architecture and a node plus 0 architecture, you're actually allowing the smaller service group to reach higher bandwidth speeds. So you're actually enabling cable operators to increase their speeds to their users, as well as having higher performance characteristics by removing all those amplifiers in a node plus 0 architecture if you go fiber deep. So lots and lots of benefits, and I'm sure I might be stealing a few of the ideas that the others will be chiming in on, but you also get longer distances and more wavelengths when you go from analog to digital fiber, which is another characteristic of DAA and remote PHY.
Okay. Anyone else want to chime in?
Yeah, I certainly agree. I mean, the fact that you transition from analog fiber to digital fiber provides you with much greater efficiency and ability to send out your signals much more efficiently throughout, again, longer distances. So it improves your throughput to your subscribers. Other than that, it provides you to bring in fiber closer to the subscriber, right? The transition is to getting fiber closer to the home, up until fiber to the home. So moving to remote PHY actually allows you to add the extra mile of adding digital fiber almost up to the house of the subscriber, getting you closer to the final goal of fiber to the home. Also, the ability, the fact that you still keep the Mac within the head end allows you to scale it up a little bit more, right? You still have better control of it inside the head end, and you're able to virtualize that, right? You're able to take that functionality and virtualize it and expand it and change it in much more flexible rate.
Excellent. All right.
So,
John,
so the bottom line for me was the biggest problem or hurdle I've seen over the 25 years I've been in the industry has been the analog link being the Achilles heel. The performance is all based on that analog fiber optic link. By getting rid of that analog amplitude modulated, intensity modulated light and going digital, the performance is much better. The MERs are better. You're basically taking the chipset that was in the CMTS and moving it out to the field. Because of the digital link, you can go much farther, so farther distances are possible. With better MER, you can run higher modulation schemes with DOCSIS 3.1, so that's on top of everything. But as an RF guy, I also like the idea that the limitation of RF ports in the head end, and that limitation now is pushed out to the field. So when we look at service group sizing and service groups, the number of service groups is always dictated by the number of RF ports. Well, there is no RF ports anymore in head end. It's digital. To do digital splitting, combining, you just go from, say, a 10 gig circuit into a 100 gig circuit. Faster circuit. RF, you can't do that. You can't just combine 5 to 42 megahertz upstream with another 5 to 42 megahertz upstream and think it's going to be separate. But in the digital realm, you can do that all day long. And with Moore's law and faster speeds and cheaper prices, blah, 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 we're going to end up with faster and faster pipes, which means maybe less fiber, more wavelengths, but each wavelength could be running, who knows, 100 gigabit per second. So the digital link is kind of the key point to start pushing us further towards virtualization, towards cloud, and giving us the opportunity to offer higher speeds. And I think that's the bottom line, right? Higher speeds. We could say fiber to the home. Yeah, we could do fiber to home with R-PHY, but R-PHY is still an analog link in regard. But if we can go to a digital link, then that's the way to go.
Excellent. I like the different perspectives here because I think that it's unique. Like I hear, John kind of focusing on the physical layer aspect, and John, I think both John and I come from more of the PHY aspect world. We both started off as RF guys, whereas Tal and Asaf are coming in from a higher layer in the realm there. So I think we all bring different unique opinions to it. So that's excellent points of view. So moving on, building on this, I'd like to talk about the complexity of R-PHY. So I think that is something that we haven't talked about in the past, because we think, well, it's awesome. There, it's a nice technology that we can push out. We don't have, as John mentioned, we don't have to deal with the analog lasers. So that's one less thing to worry about. But are we introducing more complex issues when we have R-PHY devices, or is it just as simple as, we just push that R-PHY out there and there's nothing to worry about after that? So
yeah, I do think it's really complex, to introduce a new architecture, no matter what that is, right? When you start up a new architecture deployment, you need to make sure all the different components of that architecture works, right? Like a new car. You want to make sure everything works together well. So it's always difficult to introduce something new into the network. Distributed access architecture, and specifically remote PHY, brings in many more devices down to the network, to the places where previously there were only passive nodes, right? So now we suddenly have hundreds of those active nodes out there in the field. We need to be able to configure, provision, do a software upgrade for, monitor, make sure the health is okay. So it definitely, upscales the level of operational complexity in terms of, the need to manage so many active devices out there in the field.
Automation tools are a necessity.
Yeah, I mean, that's interesting. You talk about software updates with a node, because anytime I've worked in nodes in the past, there's just optical to electrical converters and some
Right.
amplifiers and signal conditioning and stuff in it. But software
No
upgrades
more.
on an R-PHY, explain more.
So a remote PHY basically consists of the physical structure, which is the node, and the remote PHY device, the RPD, that sits inside the node itself, executing the remote PHY functionality. Basically, the PHY functionality that was previously residing within the CMTS or the CCAP, right? So when you have the processors, FPGA, that sit inside that remote PHY node, they actually have a software upgrade, just like you would do a CCAP software upgrade, right? So when you need to add more features, more capabilities, and you would want to do a software upgrade to that active component that sits inside the node. So all of a sudden, you have hundreds or thousands of active devices out there sitting in nodes in the street, in cabinets on pole, that you have to do mass software upgrade for all of them. You need to have the ability to orchestrate and provision all those devices in an efficient way. You can't really count on CLI commands and type in manually different types of of execution commands. You're not going to scale, right?
Sure. So John, I remember at SCTE Expo, you were showing me like a small handheld device that you were plugging into an R-PHY node. Is that kind of what Tao is talking about as far as like, provisioning these things or managing these things? Is that how it's done?
I think so. I mean, what we were showing at Expo was a regular smartphone with an app, and that app can be downloaded today. But today it works with our iNode. So our iNode has intelligent node. It allows you to plug in through a USB, upstream spectrum, downstream spectrum, set the pad to EQ. There's no plug-in pad and EQ. It's actually controlled via software. The next iteration would be you can do that over the network itself. Because who's going to climb a pole with a smartphone to set up the node when I can do it from the comfort of my house? So that'll be part of the provisioning and setup. I foresee RPDs being pre-provisioned in a warehouse and then actually sent out with the contractors, subcontractors to install. And then we have a QR to that device, and it would do a lat long so you could see exactly where that node was deployed. So you already have a pre-provision for levels, the settings, all pre-configured. The contractor technician takes it out, loads on the pole, but maybe because of that pole's in the middle of someone's yard, they have to go one pole back. But at least it will tag it once it is loaded and installed, that I know exactly the lat and long, what is it, GIS?
Yeah, geographical information systems.
Yeah, so I can have the location of that device, and then I can keep track of it. Even the iNode has some security features. If someone steals it, it basically locks you out. So there's things that you always have to consider with security, and now you're putting the network out in the field, and can someone hack into it? Like someone said, instead of requiring a USB for me to plug in, why don't you do Bluetooth or wireless? I'm like, well, now you're talking security.
Right.
That makes sense.
Yep, absolutely.
By the way, up front, the complexity I'm saying, I wish we didn't have this complexity, is we added, when we went from modular CMTS to distributed access architectures, we had a timing server. I used to hate it, the DTI server. And then I thought when we went to remote PHY, it was IEEE 1588 timing, so it's part of a standard. We wouldn't really have that requirement, but we do. We have a PTP, so that still requires a timing server. Hence, it's much cheaper and easier to get than from one vendor back in the MCMTS days, but it still adds complexity. You have to set it up and make sure it's ready to go and understand the configurations, stuff like that.
Is the timing server, and I'm digressing here, is the timing server still like a Symmetricom timing server? But I mean, you said it wasn't, we're not, and I'm since I'm the agnostic guy here, is it no longer a Symmetricom timing server, or is it just from someone else, or is it vendor dependent?
I think the Metricom might have been sold to one of the companies that does provide the PTB. It's Microsemi, maybe. Right. And the other one is ADVA. ADVA. So there's a couple vendors. Before there was like one vendor.
Tao, go ahead.
Yeah, there's the Silic quartz as well. So there are a few of them offering different types of solutions, from a server to a potential SFP plus kind of device that would fit into one of the chassis, or that are the CCAP core basically. It does add complexity for sure, right? It's yet another device that you will need to manage and provision, make sure it works, make sure it synchronizes. So it adds a little bit of a complexity, but we're thinking of more elegant solutions to try to make it less of an interfering problem.
Cool. I like the fact that we're not tied though to just one vendor that provides this timing server. And that is your only solution. Thank you. We will charge you whatever you want. So Asaf, what's your input on this, as far as like the complexity and some of the issues that you're seeing?
Well, I think it's an evolution. It's MHA v2 for a reason, and DOCSIS is complex.
Oh, sorry, what does that mean? What is that term?
Modular head-end architecture. Modular CMTS was built on a technical report in Cable Labs called MHA. There wasn't a V1 to it, but now that there's a V2, you add a number. And it's the evolution of that. And there was, I would say, an inflection point of when that made it relevant is when you had silicon out there or FPGAs out there that could do the full spectrum. Because once you separate the physical layer from the upper layers, you want to put it out there and have it live a long time. You don't want to replace these things out in the field. And now that we got a full spectrum DOCSIS and the downstream 3.1 and the downstream and the upstream available as basically commercial silicon, that's something that could be separated very easily, number one. Number two, in terms of the protocol, it really is an evolution of modular CMTS. We use the DEPI plane and control plane there. We call it DEPI and DEPI control. And over here we have DEPI, UEPI, the use for the upstream, and GCP, which is just a newer version of the DEPI control plane. So an evolution there as well. But we're basically taking something that was, by all regards complex. DOCSIS is complex, and evolving it in a way that allows us to take something that is slowly changing, that's long lasting in the field, the node, and separating for things that hopefully are faster evolving. The software, if you have a virtualized approach in the head end and a CMTS core, you can have those things change very quickly. With regards to the software upgrade, it's a great point. Those are active components for sure, and those protocols need to be digested in the node. But there's another active component out of the field that is even deployed in a much greater magnitude, which is the cable modem. And in fact, there's some operators who are doing software upgrades to their cable modems very regularly, at least weekly, if not more frequently, and very successfully. And certainly, I would look at modular CMTS and the frequency of updates to the universal edge QAM, right? To that piece of it. It was very infrequently upgraded because the physical layer isn't changing very fast. So you have to have the capability to download software to these nodes, but it shouldn't be changing. And when they are needing to be changed, it's something that's simple and straightforward and really well defined, as well as secure. Cable Labs took a lot of steps to making sure that it's secure and well defined, learning from its great experiences with the cable modems already out in the field. So there's been a lot of thought around that already in the industry, and it's proven out in the field as well.
So when you mean secure, security in the R-PHY, like what are some of the things that we have to worry about from a security standpoint?
Well, you got encryption. DOCSIS has its natural encryption, but also security. Modems have certificates, right? They get issued certificates that are mapped to their MAC addresses, and so do remote PHY devices. So these things are out there to make sure that they're not spoofed, that the link is encrypted, and that basically they're known entities, right? So somebody can't just put something out on a pole and expect to get service. So that we need security and encryption and authentication, not only for cable modems, but also for remote PHY devices. And again, we're leveraging known techniques out there that are well used and applying them to these devices as well.
So does this tie back in, John, to what you were talking about as far as like if someone steals an R-PHY device, and we know this happens. I mean, people steal nodes, they steal amplifiers, they send them to other countries and get deployed. I mean, I like that concept that someone steals my R-PHY device, it's not going to be usable. So that reduces the incentive for people to steal R-PHY devices and start stealing equipment. Is that something? I mean, that's real, right?
Unless they steal for the precious metals. That's a different story.
Exactly.
Yeah. So, I mean, I like that concept. And is that kind of tie back into what Asaf was just saying, that it's almost like a cable modem with a BPI plus certificate, where if it's authenticated to a particular, does it get authenticated to a cable operator or to a CCAP? Is that essentially what's happening?
I mean, it would have its own MAC address or identification that is then talking to the core. So you have your CMTS or CCAP core, CMTS, or it could be a virtual server, but that ID has to be tied back. So I don't know all the details into that side of it, but yeah, it's not like you can just throw an RPD out there and think it's going to work at all.
Yeah, I think the major catastrophe scenario that we're afraid of in this regard is that somebody will spoof the remote PHY node. And imagine somebody pretends to be a remote PHY node that got access to the Mac core, right, to a big box that can serve up to 60,000, 90,000, 100,000 subscribers, and they got like a full open, gateway to that big system. They could take it down, right? Where basically with the remote PHY out there in the field, we're punching a hole in our so-called security system and allowing people, if somebody spoofs a remote PHY, they can just get into the the Mac core and be able to and be able to.
You can say E6000. We can do anything here.
Yeah, it's automatic. I don't even think about it. You can just get into the Mac core and be able to take down everybody else, right? Take down 90,000, 100,000 subscribers, potentially even spy on them, right? You could potentially take a look at the traffic that they're getting. So we really need to make sure that nobody can spoof an E6. Remote PHY. Now I'm not going to be able to stop saying it. Oh my God.
It's all good. We're all friends here.
We need to be sure that nobody can really spoof a remote PHY node. So basically, we have a certificate. We got a couple of ways to secure that. So there's an operator key that is there. The operator configures that and downloads that to the actual remote PHY device, so that the operator is also got an identification versus the remote PHY device. And we also have the Mac core is able to identify the remote PHY device that is connected to it and verify it. So unless there is this dual handshake using standard protocols for that handshake, there's not going to be any identification for both sides, right? Somebody could also potentially spoof the Mac core, right? So both sides of the equation, both the Mac core and the remote PHY, both need to be authenticated and verified, such that there's not going to be any middleman attack in that scenario.
That's really, really interesting. I had never considered the security aspects of that would even happen. I mean, they go well beyond the normal security issues. That we have lots of security is huge in the news. Security is huge everywhere, but this is just adding another layer. Are there other types of concerns that R-PHY introduces? I mean, with security is one aspect, but I would imagine there's a certain type of time that it takes for the R-PHY to register and do this type of handshaking. How much time does it take the R-PHY device to register with a CCAP?
Relatively quickly. And yeah, I mean, the protocol is there and it's relatively quickly. I think the long pole in the tent and how long it takes an RPD to come up is synchronizing with the 1588, the IEEE 1588, and depending on how that's configured. But other than that, those things come up very quickly, and it happens when it gets powered up. So generally speaking, it's a pretty fast process.
I like how you don't put a number on it. Very fast and very relative.
Put a number on it. Fair enough. We've experienced around 3 minutes. And I don't know how long it takes for folks to wire it up on a pole and connect power. when you think about it from a strand-mounted experience, but 3 minutes for a technician who put something on a strand is a pretty insignificant amount of time for the amount of time it takes to install it.
So if it takes 3 minutes to come up, I mean, on the first time on a power outage, what happens if there are like network glitches or anything? Is there anything that would cause the R-PHY to go offline and have to re-register?
Yeah, potentially that could happen. You know, if you lose connection to the Mac core or to the aggregation router that sits on the way, potentially yes, the remote PHY can reboot and kind of re-register. So you would say it for a cable modem. The registration process is basically establishing the tunnel towards the Mac core of the GCP control that Asaf mentioned that needs to get established so that traffic can start streaming. That happens very, very fast as well, right? So it should be, you know, almost instantaneously when you have a disconnect that the new RPD, the RPD will come back just like a new one and re-register to the Mac core.
What other things should operators be thinking about, like when they're thinking of deploying R-PHYs?
I think you started a good segue there from complexity to hurdles. I see would be you're replacing all the RF and head end out to the field. So what else replicates or produces RF that you need to now replicate out in the field? Sweep signals, leakage detection signals, out of band set-top box signals, return path monitoring equipment. There's no RF in the head end. So we've talked about this. You support those services, and do you even need to have those services anymore? It's a smaller targeted area. So that's one aspect of it. And those are being addressed as we speak. The chipset in the node, the RPD, has to produce the RF. So video QAM, DOCSIS QAM, DOCSIS 3.1 QAM, out-of-band signaling, could be FSK, BPSK, whatever, QPSK, whatever it happens to be. CW carriers for leakage detection, if you're still doing that. Be RF spectrum and send it back on a digital link so I can process it. So all those things have to be supported. Almost like we have to be backwards compatible with whatever we do in the head end today. Actually, our hurdle, I feel, is so supporting the RF, and there was another one. Oh, redundancy. People are like, well, what if it goes down? But then again, you could turn back and say, well, what if your node goes down? You don't have redundancy there either. Most people don't.
Right.
You know, they might have battery backup. Oh, yeah, but I'm hitting all these data subscribers. It's still the same node. It's still the same number of homes passed per node. So you can look at it and say, our MTBF is much better with the digital link. Or you could do it separate fibers. You know, you could do multiple fibers for redundant fiber. But the complexity, that's why I think Cisco and a lot of industry focused on remote PHY, not remote MacPHY. I know remote MacPHY is going to be part of Cable Labs as well. Put the least complexity out in the field, but be future-proof for your hardware. As if I can never pronounce your name, Asaf.
Asaf, like a sophomore, but Asaf.
So as you mentioned, I want to be able to have something that's really reliable out in the field. And, you know, the complexity is not really out in the field. It's just the PHY, but you want to be having future-proofed, meaning it's 3-1 upstream, downstream that you know you can utilize for the next 10 years. You know, it's not going to be something where you need to replace hardware. If I need to do an iOS update, it's much simpler with automation. Granted, you're not just updating 10 CMTSs, now you're updating 10,000 RPDs. But you can do that in a round-robin fashion, much quicker, and maybe you're only updating the BGP part of it, or an FPGA upload, or something that's very minuscule or minute, versus updating an entire CMTS.
Yeah, I agree with John. I mean, one of the things that you nailed, I think, that is different is the end-to-end remote PHY solution that operators need to be aware of. You mentioned all the right things, but it's worth repeating. Out of band, right? SCTE 55.1 or 55.2. The video core everything needs to be over IP, right? Because it's a digital link. So you don't have any RF combining in the head end. It happens device. In Europe, also, there's FM signals, HMS signals. So all those things, leakage detection, those are all things that need to be there to make it end-to-end complete. And PNM is an important part of this as well. Brady, I know that you're really well aware of that as well. But when you start looking at the signals, you were looking at it because you're receiving the RF at the head end. Well, you're not going to receive the RF at the head end, so you have to be able to send those signals a different way over IP from the remote PHY device, so you're able to monitor and manage that centrally, right? And definitely allowing your technicians to still have the capabilities. They're super capable people, but you want to make sure that their job is very similar to what it is today. Yeah, they can scan a QR code and they can install that, but at the end of the day, you want to be able to also provide the key tools that allows them to manage the technical part of their network. So those are all things that make it a complete solution, as well as, not to mention, the CMTS core itself. Those things all exist today, but of course, the way they get transmitted between the head end and the node is not over an RF link. Now it's over IP. So that's kind of the difference there.
Yeah, there was one more signal that we need to replicate from the RPD. I forgot, but I'm glad you mentioned FM, which is, you wouldn't think many people carry FM, but I think in Germany they do. Radio frequencies 88 to 108 on the cable plant. So that has to be figured out. Most think that we should just get rid of FM and do digital satellite for radio, but hey, it is what it is. The other one was CW carriers that are frequency agile, maybe for existing amplifier HECs. So we have to make sure that we have signals that we can produce if we still have, say, a node +3, node +5, level control or automatic gain control in those amplifiers that might not be able to monitor an OFDM signal. Maybe they can't understand a QAM signal, but they still require, in essence, a CW, something very stable and frequency agile. And typically when you do a CW carrier, the AGC is looking for 6 dB higher than a digital carrier right next to it. So you have to make sure you have level flexibility as well. So that's another thing that's been asked.
Yeah, I would take it to a different angle, if you don't mind, Brady. I think that a couple of not so much as hurdles, but more like planning items would be routing and the video architecture. So on the routing side, when you have to send out the traffic from the Mac core to the remote PHY node, you need to, in most cases, pass through aggregation routers. It could be spine and leaf switches on the way. There could be a layer 2 network or it could be a layer 3 network. Both would work, right? It really depends on the customer preferences and whatever architecture they've got in their backbone. But it's important to remember this one and do the planning ahead of time to think what kind of protocols you want to deploy in your IP backbone, right? This is what carries your signals down to all of your nodes. So you need to make sure that you have the right protocols, you have the right network design, whether it's with or without link redundancy, as John mentions, to the RPDs themselves. You need to make sure that all those switches and routers that sits on a way, they support the features that you need them to support, like potentially security features like MACsec, or the multicast distribution that you require for your video signal distribution. All of those need to be thought of and make sure that you have those. And also you would want to start thinking about how do you provision those, right? When you have so many switches and routers down there in your network and your spine or leaf, you want to be able to provision them, configure them the right way to make the signals flow from the Mac core to the RPD in the right way. And you want to probably automate that, right? Automate all the CIN, the converged interface network, interconnect network. It's everything that sits between the Mac core and the remote PHY. You want to be sure that you know what you're putting in there. You can provision it, configure it remotely. You don't need to go, again, manually to configure each one of those devices. The second item is you need to make sure you plan your video network accordingly, right? A lot of customers have got different types of broadcast, VOD, SDV type of requirements in terms of narrowcast and broadcast video. And you want to make sure that you can, in the standard, according to the remote PHY, it supports, VOD, SDV, broadcast, it's all supported. You want to make sure that your configuration is aligned, right? That you replicate the broadcast to the right nodes. You got multiple edge zones you need to think about. You need to make sure that all your video architecture is really well aligned with what you're planning to do with the DOCSIS and high-speed data and voice type of architecture. And there are different approaches to that, right? There's an approach that says, okay, converge everything on one Mac core. There's another approach that say, okay, why don't you split the core? Have a core for video, a core for DOCSIS. That's another acceptable approach, right? But each one needs to do the analysis, make sure they do the right planning by themselves.
Wow. So I just know if I'm a cable operator, I want all three of you to be right beside me when I'm making my choices to start deploying R-PHY. But the one thing I really like that you just mentioned, Tal, is automation. So because there's so much complexity that goes into this, but if you can automate that, how do you start going about automating some of this actually to start simplifying the complexity that goes into R-PHY deployments? Is that something that we can see on the horizon, that it can actually make it simpler for operators to get this stuff out there?
Yeah, definitely. I think all of us are working on those domains. So without mentioning specific products, we're all aware of the problem that so many different active devices down there in the network basically create a configuration nightmare. So we need to be able to automate the configuration, the setting up, the changing parameters and reconfiguration of those devices. And the only way to do that is through automation, right? So automation is the most basic way to say, okay, let's do a script that does CLI commands in a row, right? Potentially. But if you take it a level above, then you would start talking about orchestration, right? Because you have the Mac core, you have the remote PHY, you have potentially the video servers, the video the video cores, the out-of-band servers, a lot of different components within the network that all of them need to work together, which brings us to a point where we actually need orchestration, right? We need to make sure all those devices are working well together, passing parameters to one another, not creating any contention in terms of configuration in the network. So this is where orchestration and provisioning tools are starting to surface, and I think all of us are kind of engaged in that front at this time.
Awesome. And anyone else want to chime in on the automation side?
Yeah, sure. I'll just compliment what Tal said. I think the industry, all of us are looking at different ways to orchestrate and automate. And virtualization, we covered that last time. This isn't a virtualization session, I guess. But virtualization approaches out there allow you to orchestrate in a pretty effective and efficient way. We're all aware of those different tools, and without sidetracking or rat holing in that domain again, I think having a virtualized approach enables those things to enable the operator to remove the operator and for making too many manual decisions, and making it in a more efficient way that removes some of the errors that are associated with such a mass configuration when you look at all the different elements that are out there. So when you look at turning on a node, you scan the QR code, John mentioned that earlier, and something automatically initiates its configuration that was predetermined and allows that service to come up almost automatically, because its lineup from a video out-of-band DOCSIS perspective has already been done and associated with the MAC address of that remote PHY node. And the whole trigger there is that it's been authenticated ahead of time. They know that that node exists and is authenticated. Orchestration, once that QR code is seen, right, in the back office, enables it to get the right configuration with the right apps, with the right type of out-of-band, with the right DOCSIS service group configuration, and basically from then just letting modems starting to register. And that's something that exists today, and we're all working on it, as Tom mentioned. And that really removes a lot of that complexity away and abstracts it away from the operator in a way to deploy these things in a really scalable way as well.
Awesome. Thank you. So if we were to look a couple years down the road, 2 years, 3 years, where do you guys see R-PHY technology going? Does it get smaller? Does it get pushed out even further into the plant? I mean, do we have any visibility on this?
I'd like to see it scale up. I'd like to see a steady state. I think 2018 is the tipping point year for the industry. You got Cisco, Arris, and Harmonic on the call over here. I hope we could all agree that remote PHY solves real world problems. And if you think back to SCTE, there was a remote PHY session the day before the show started. I was lucky enough to participate with John Chapman and Tom Coonan and Nokia in a panel, and we were expecting about 100, 150 people, and all these folks showed up, and it was at least 3 times that. So there's a huge interest for that, and I think remote PHY, first of all, needs to be deployed in a scalable fashion in terms of how much of that footprint is actually going to use the technology. So I see that as a big thing that happens in 2018. I believe that Jeff Hainan from SNL Kagan put out a report recently that showed that there's a shift from traditional HFC nodes to remote PHY style nodes, and has an estimate of how much that will happen over the course of the next few years as well. So I think the technology is really solid with full spectrum. It'll last a really long time, and hopefully we see a lot of that inflection point somewhere during 2018.
Anyone else care to hazard a guess?
I'll take a risky guess, maybe not a popular one, but I think in 2 or 3 years from today, we'll see a great variety of solutions out there in the market. I'm sure we'll be widely deployed with remote PHY. I'm sure integrated CCAP is still going to be very strong, potentially #1 type of solution out there in the market. We'll see more remote MEC and PHY. Potentially we'll see more remote MEC, remote PHY sitting next to one another. I think we're headed for bifurcation in general, and I think that in a few years from now we'll see a little bit of everything. Remote PHY is an efficient solution for a lot of customers, a lot of cases. It's very helpful for customers looking to, again, push the fiber down closer to the subscriber, or it could also be very efficient in case of rural areas where you have smaller hub sites and more remote locations, where you could just place a node and feed an entire, a group of homes potentially, or you could just put a remote PHY shelf, which is another viable solution, right? It can sit inside a small hub, where the actual Mac core is going to be sitting inside a head end, a centralized head end. Years from now, we'll see just about everything out there, right? We'll see remote PHYs in nodes, in shelves. We'll see remote MEC and PHYs out there in many cases, and a lot of integrated CCAP that will keep living for many, many more years.
Okay, so both you and John have mentioned MacPHY during the conversation, and I've also heard other discussions of MacPHY. And it's my understanding, the MacPHY, we're basically pushing the intelligence of the CCAP into the R-PHY, if I understand that correct. And you can tell me if I'm wrong, but what solution is MacPHY solving over just a standard R-PHY?
Yeah, it's a good question. I don't feel like being the only one to talk, but yeah. So remote MEC and PHY basically takes the MEC functionality, put that inside the node along with the PHY. It tells a few things, right? There are some few benefits to that. One of the benefits is that you place the MEC and the PHY closer to the subscriber, right? Again, you would send out digital links of IP down to the node, and then you will do the MEC and PHY functionality and spread it out to the home on smaller service groups, right? So you get the benefits of digital links going to that node, right, with higher throughput. The fact that the MEC and the PHY are located together inside the node allows you to provide better, less latency in terms of the services, because the scheduler, which sits in the MEC and the PHY level, sits together, so that potentially prevents some latency issues that may arise from a remote PHY type of architecture. And this is something that a lot of discussions are raising today because of the concern about the gaming community, right? About the gaming requirements for latency within the network. So that potentially solves this problem. Another, there are simplifications that come with remote MacPHY. So, for example, the fact that the Mac sits next to the PHY reduces the need for the timing server that we just mentioned. So one less item out of your off your architecture, off your ecosystem. So that's nice, right? There's no need for the actual protocol, the DEPI protocol, or GCP protocol between the headend and the node. They will all be sitting together. You only have IP, right? You have IP down to the node. From that on, that's RF. There is no need for yet another protocol, which is the DEPI or remote PHY protocol and spec that is now emerging. So some people, look at it as a more simple solution to deploy, because you just put a box in there, turn it on, bam, it works. There is no dependency between the node and the Mac core sitting inside the headend. To some extent, you can think of it as a simpler architecture, but it's got its own challenges, like power and heat. When you put the Mac down there, it's much more complicated to manage the heat dissipation. So pros and cons to each one of them, right?
Yeah, and I would add to that we'd like to see the remote MacPHY, for it to get standardized. Right now, it's not a standard solution. There's a technical report that describes conceptually what Tal mentioned, but you can't replace remote MacPHYs today with other remote MacPHY solutions. So the standard is having a standard solution there, I think, is important. So you have interoperability as well. So that's a good point. There's something that's usually overlooked in terms of the latency that's worth mentioning, since we brought up remote MacPHY. DOCSIS has a embedded latency with best effort services related to basically the scheduler, right? And John Chapman actually covered this in the remote PHY session at SETE, which is integrated CMTSs and remote PHY have the same latency as we are familiar today within the distances that most DOCSIS operations are deployed in, which is 100 miles or less. And the reason that is, of course, you have to take into account that the DOCSIS maps need to traverse, even if there's no distance, they have to cover a certain period of time of allocated time slots, and you have to wait for the modem to reply to that. Even if there's no propagation delay, you still have this back and forth. So typically, the minimum latency, whether it's remote PHY or remote MacPHY, you still have about 5 to 6 milliseconds best case latency, no matter what. Even if the Mac is sitting 1 foot away from the modem itself. And it'll be interesting to see what happens with the standard, and I think we're all participating and keeping well aware of that.
So that was one of the big issues, or perceived issues, was distance and latency. Our own testing to prove that with remote PHY, even though the Mac was potentially 2,000 kilometers away, there's 2,000 kilometers away, we simulated that with real fiber and also a latency simulator, that we were able to still basically reach line rate with DOCSIS 3.0 modems. Now, if you're talking about, and this is upstream speed, right? Because to request all the way down to the Mac, because that's where the Mac scheduler is and the upstream scheduling, and then sends a downstream map to say, all right, now you can send on the upstream. So that upstream speed is what the problem is. It's not downstream. But we were able to show that with DOCSIS 3.0 doing MTC mode, multiple transmit channel set, continuous concatenation fragmentation, that basically we can get line rate on the upstream, even with a 3.0 modem. Now, if it's a 2.0 modem, yeah, you might not get better than, say, 3 megabits per second if it is super long distance concatenation. But my feeling is, if I'm going remote PHY, I'm offering higher speeds, why would I be relying on a 2.0 modem to begin with? And if I had a 2.0 modem in the customer's house, maybe that 2.0 modem was embedded in the set-top box. So that's why it was still a 2.0 modem. It's per second on the upstream. They only need what? 300K or whatever they did for their set-top box. It's just DSG, DOCSIS set-top gateway. So the distance-wise, the argument on distance hold a lot of water. But the gaming and latency, I think that one still needs to be vetted out and proven. That is there really an issue with gaming and latency with a remote PHY solution, or is there some other option or feature I can implement to turn around that request grant a little bit faster?
Yeah, you could always put it on a UGS flow. I mean, that's what we do with voice. We also have to understand it's if it's actually impactful to the experience. So far, it hasn't seemed so, but obviously that will depend on the distances we're looking at, and they're going to be pretty extreme distances. They're going to be much greater distances than what CMTSs are deployed for today. We're talking, multiple hundreds of miles between the scheduler and the remote PHY and the modem, effectively, which is
we could envision a data center in Central America, in Central USA, feeding remote PHY devices across the entire United States.
So okay. I sense that there's going to be a lot of future debate between MacPHY and remote PHY. This seems to be an interesting topic, and it's very interesting that gamers are the ones that are noticing it the most.
Well, there's speculation that they'll notice the 1 millisecond extra latency over 100 miles, which is what it is, right? The speed of light over fiber is 0.8 milliseconds per 100 miles, and there's speculation. I still think that DOCSIS still has the capabilities with UGS flows to manage gamers. We could always put them on that type of service flow. But I want to mention something that Tal mentioned, and I think it's important, is the power, right? We have a power budget for these things, the nodes that go up on the pole, and really, it's really hard to bring in more power into the field. So technology, you mentioned how technology will evolve over the next few years. Probably the remote MacPHY piece will come down in their power consumption. And of course, remote PHY today, I'd like to see a bake-off, but clearly I think that remote PHY is much less power consuming when you look at the power specs of our node solutions that are available today. I think that's an important thing to mention, because you can't all of a sudden show up and, on the head end, you could always bring in more power, cost more money, but you have that opportunity. In the field, you just don't have that opportunity, right? So that's an important point that Tom mentioned.
Awesome.
Yeah, we could expand on that actually even more. If you want to take it another step up, the fact that you keep the Mac functionality within the head end allows you to, expand it, change the devices that support the Mac processing, right? So for example, DOCSIS 3.1, a lot of the changes that DOCSIS 3.1 introduced were done in the Mac level, right? If you would have put a chip, down the line in the node, and then you wanted to upgrade to DOCSIS 3.1, or now when you want to upgrade to FDX, going to be pretty difficult to do, this next technology jump to FDX, for example, without actually changing the device down there in the node. If you're keeping the Mac within the head end, it's much easier for you to actually do that change, right? You're able to change the devices, virtualize them to some extent, move them, around, and because it's all in the head end. Once it's in the field, the churn, the fact that you need to take it out and put it back in and replace the device, it's much more expensive, much more complicated, right?
Perfect intro to the last question for today, Tao, was final closing question. What are your thoughts on where remote PHY and will full duplex DOCSIS, will we see that happen? Will it occur in the next few years? What are your thoughts on that? Tal, we'll start with you since you did the lead in on it.
Okay, that was an ordered one, right? So yeah, FDX is a huge promise, right? We can't wait to see it happen. It's going to be a very big relief to a lot of the upstream requirements from our customers. FDX will materialize in the remote PHYs and remote MacPHYs, both of those. And it's going to happen in the next few years. It's going to be a little bit longer than I think the advertisements would say, right? You still need to manufacture the chips, the ASICs for the modems. You need to make sure that the remote PHYs, remote MacPHYs will support this type of technology. A lot of testing needs to get done. Just as an example, DOCSIS 3.1 spec was sealed, a couple of years ago already. we're still, we're just starting to see the vast deployments of DOCSIS 3.1 right now all over the world, right? It's just, it was just starting in the last few months or so. So it takes a while to adopt this new technology and really deploy that widely, but it's going to happen for sure for FDX, considering the requirements of that technology, which would mean a node plus zero type of architecture, fiber deep type of deployment of the node and its logic.
Okay, John, your thoughts?
I mean, let's take a step back and ask, what is FDX solving and why do we need it? We know DOCSIS 3.1 increased upstream to 204 megahertz, which gives us more 3.1 upstream. But then FDX came around and said, how do we get to 1 gig on the upstream? And we're not going to be able to do it with DOCSIS 3.1 across the board and efficiently share that speed. I might be able to get 1 gig for one customer, but I need to sign up, 300 customers sharing that same spectrum. So how do I do that? And one of the ways is get rid of the diplex filter, do full duplex DOCSIS, introduce something called echo cancellation, new technology. I liken it back to our feed forward days of our C-core amplifiers, right? Sample the signal and delay it 180 degrees out of phase so you could cancel the signal. But it's sorted to that nature, and I don't know if they'll call it DOCSIS 4.0 or DOCSIS 5.0 or iPhones DOCSIS X or whatever we're going to call it. But it is going to be new hardware. So the modem might need an echo cancellation. The node is going to need echo cancellation. The actives need echo cancellation. You need smart functionality that the modems can transmit while the CMTS looks at other modems to see where the interference groups are. So it has to be able to bundle that. So sort of automation again. So you can bundle or cluster devices into non-interfering groups. It's called full duplex, meaning simultaneous downstream and upstream, which seems really crazy when you're an RF guy. How can I transmit at 500 megahertz on the downstream or receive 500 megahertz on downstream and transmit on the upstream at 500 megahertz? How can I do that? Well, there are ways to do it. So it's kind of interesting where those things are going, but we're trying to introduce this to solve the problem of offering 1 gig service on the upstream. How you mentioned about DOCSIS 3.1, yeah, it's being widely deployed now for downstream, but I don't really see any upstream. No one really has a spectrum. Anyone that's updating cable plans today is going to 85 megahertz on the upstream. So I might be able to do 5 to 42 megahertz for single carrier QAMs, ATDMA, and 42 to 85, I might do a small block of OFDMA. And then I can aggregate all that together and maybe offer 100, 200 meg service on the upstream. But until we get an application or competition to push us on the upstream speed, I don't know what's going to really push us for the FDX. Something's got to push us. And that could turn around tomorrow. This new application could come out tomorrow. Then home security, high definition home security. I don't know. Even on the cloud and the virtual side, we could sit there and say and be prognosticators and say it'll be 5 years before I see this. Well, it could take someone like Amazon tomorrow to buy Altice USA and say, hey, we're going to go cloud, and just kind of rip everything out and go cloud, because they have that infrastructure. That's the way they would do business. Amazon and Google, they rather have big data service centers and not deal with the CMTSs and stuff like that. So, I mean, we can try to guess. and I know the hardware is not going to go anywhere soon. It's return on investment. But it wouldn't be hard for us to start implementing these new technologies on a as needed basis. I have a business park that's opening up down the road. It's greenfield. I'm going to do a fiber as deep as I can. You asked about how deep? Node plus zero. I could foresee that going fiber remote PHY taps eventually, going down that the node is only feeding 8 customers. You're just going to get closer and closer. It's still to the home. 8 people sharing that node versus 1 person sharing a node. It's still cheaper.
So I hear
this comes down to money.
A resounding yes from Tao. A really kind of I'm not so sure from John. Asaf, you're going to be the tiebreaker.
Okay. Well, I think putting your money on speed is always a good bet, and it's proven out all the time. And putting your money on HFC. So FDX is a bet on cable networks, and it's a bet on speed. And I think we'll get there. And and it's a good bet. And in terms of, I think it's funny, John. I don't think it's 4.0 or 5.0. I think it's an appendix in 3.1.
Appendix
right?
F.
It's
Appendix F.
Yeah, it's a simple change, right? It's only full duplex. It's an appendix.
What happens when I have appendicitis?
Yeah. You'll choose which appendix to remove. So I think that it will happen, and we're investing a lot as an industry to make sure that it does happen, because it gives extra life to the investment we've made into the infrastructure and of the cable plant, and competing against fiber to the home. And the competition is symmetric speeds, right? We still have customers that need symmetric speeds and need to have that upstream bandwidth to compete against that. And that's FTTH, is that you could sell not only high speed downstream, but have symmetric upstreams. And this is what will give that lifeblood. DOCSIS 3.1, by the way, does already an amazing job of giving upstream speeds if you have the spectrum. And FDX basically gives you more spectrum and the ability to simultaneously transmit over those same frequencies. So it gives you more upstream speeds. Obviously, there is some trade-offs in the downstream, and making a mid-split decision or a high-split decision of where that happens. But without question, it'll happen. I do agree that first of all, we're going in record speed as an industry in terms of specifying it, in terms of the folks making the chipsets out there. But then they have to be put into products and tested and put out there, and it takes time. And we can look at the history of how long it takes for that to happen, and how long it takes to scale deployments for that to happen. But I guarantee you, folks are going. All of us are going as quickly as we can in the direction of FDX as well.
Yeah, I'm going to cast my vote as a yes, FDX is going to happen, because I have to recover from my lack of support for DOCSIS 3.1, and it has done so well. So I do believe FDX will happen, or at least that's what I'm thinking now. So, folks, I'm going to wrap up this podcast, or this hangout and podcast. Tal, Asaf, and John, thank you so much for your time today. This has been an exceptional amount of material and great topic that we've covered. Our next episode is going to be on cable access SDN orchestration in February, I believe, with John and Tal, if we can get Tal to join us again. Cable access SDN orchestration, which Tal, you already mentioned a little bit, is a tool that helps us manage all of this complexity that we're dealing with now. So we do our best to bring our audience great technical content every month. If you're watching us, please click subscribe on YouTube, or you can listen to the audio version by getting us on iTunes or the Play Store with your favorite podcaster. So thank you so much for watching, and thank all of our panelists for joining. Again, everyone, have happy Friday and have a great weekend. So long.
All right. Take care.
Thank you.